I'm Pete Zelinski, and we are demythologizing DMLS, Direct Metal Laser Solidification, or laser powder bed fusion, in a series of videos with EOS here at their Austin, Texas facility. We are talking about misconceptions around laser powder bed fusion that result from the fact that this technology has advanced so quickly. So I'm with Ankit Saharan. He is the Metals Technology Director with EOS's Additive Minds group. Hello, Ankit.
Hi, Pete.
Let's talk about speed. DMLS is a slow process, or is it? It is a 3D printing process in metal, builds in layers that are about the thickness of a human hair. And so for any part, you've got to ask, how many hairs high is this? Build times are in hours. Sometimes they're in days. How do we understand the larger context of that? How does the speed of laser powder bed fusion compare with other means of producing metal parts? And how do we even make that comparison?
Speed is money at the end of the day. The build or cycle times, as tradition, comparing cycle times, if we use the same language, are quite a bit longer than you would see from castings and forgings. But I think that's not the full picture. Even if the casting and forging takes an order of magnitude less time than the laser powder bed fusion process, you still need to do a lot of pre-work in terms of tooling, in terms of setup, in terms of post-processing at the end of the day. And it's very well known in the industry that if you need a casting for a specific part, if you need a forging, your lead time is months, sometimes in years, depending on which industry you're in. And I think that's where additive manufacturing flips the problem over its head. You can have a part in your hand in days, not months.
I want to sort of amplify the point you just made, because if we look at a build time for laser powder bed fusion, it is not necessarily reasonable to compare it component to component, because it is so near to net shape. There's machining you don't have to do. And it integrates so much that there is assembly you don't have to do. So the valid comparison isn't component to component, it's the additive component to the component plus the machining plus the entire subassembly that it goes into, and all of those steps.
We've been able to sometimes even eliminate whole BOMs and simplify the procurement chain, because now instead of like procuring maybe 4 or 5 components, you're doing like one monolith piece. It's changing not the way people make, but sometimes even how procurement is done.
Okay, all of that describes the context that the speed comparison figures into. But in addition to that, laser powder bed fusion machines have gotten faster over the years. We have seen what started out as being always single laser machines develop into the use of multiple lasers. That increases speed, and quantity of lasers is not even necessarily the most impactful advance that has accelerated metal 3D printing. Can you talk about that?
One of the obvious tools is layer thickness. We talked about layer thickness and a part being like how many human hairs you have. You want to take a thin hair versus like a thick hair. People have been able to go 90 microns, in some cases even to 120, 150 microns for certain materials to increase the speed. The thicker layers you have, the less scanning you have to do, the less passes you have to do, the faster your process is. Another one that I always talk about, you have to look at different scanning algorithms and even look at technologies like beam shaping technology. What beam shaping allows you to do is you got a wider melt pool. I don't need tracks placed so closely together. I can start placing them far apart. And sometimes we've seen production gains in terms of 30, 40, 50%.
When we talk about speed, what we're really talking about is cost. For higher volume production parts that employ laser powder bed fusion, what are we learning?
When you start going hundreds of thousands of parts per day, I think the cost drivers quickly shift. Your cost driver for the machine is reduced. I think in high volume production, there's a lot of focus on capital equipment costs at that point, which is true. But if somebody zooms out and looks at a big picture and look at how many parts they're producing, they would realize they should be looking at optimizing the material cost. They should be looking at optimizing their OpEx cost. They should be looking at automation, lights out. They should be looking at labor time in terms of like how much overhead is needed to actually get these machines to work. I think that's where true speed of costs, like speed optimization or cost optimization, would come from.
Thanks for watching. We've done other installments on laser powder bed fusion and what it's capable of today. Check out other videos in this series.